So good day, sir. My name is Efel Suarez Tintorio, and I'm the first reporter. The topic of a mass balance, also called a material balances, is an application of conservation of mass to the analysis of physical systems by accounting for material entering a living system. Mass flows can be identified which might have been unknown or difficult measured without this technique. The exact conservation law used in the analysis of the system depends on the context of the problem, but all revolve around mass conservation. Example, that matter cannot separate or to be created spontaneously. So we have a differential mass balance. A differential mass balances is used to generate differential equation that can provide an effective tool for modeling and understanding the target system. So here is the differential material balances. First is the ideal batch reactor or stirred. The ideal completely mixed batch reactor is a closed system. The mass balance for a substance A becomes in plus product is equal to out plus accommodation. So here's the formula. 0 plus R sub A B is equal to 0 plus dN sub A over dt. Here is the example of ideal batch reactor. We will show you how to use a mass balance to derive a relationship between the percent excess air for the combustion of hydrocarbon base fuel oil and the percent oxygen in the combustion product gas. First, normal dry air contains 0.2095 mole of oxygen per mole of air. So there is 1 of O2 and 4.773 of dry air. For a stoichiometric conversion, the relationships between the mass of air and the mass of each combustible element in a fuel oil are. So you can see in the PowerPoint, carbon is equal to mass of air, which is mass of air is equal to 4.773 times 28.96, and the mass of C is equal to 12.01 is equal to 11.51, and the hydrogen mass of air is equal to 1/4 times 4.773 times 28.06, or rather 28.96, and the mass of each is 1.008 is equal to 34.28. And another is the sulfur. Mass of air is equal to 4.773 times 28.96 over the mass of S is 32.06 and is equal to 4.31. Considering the accuracy of typical analytical procedure, an equation for the mass of air per mass of fuel and stoichiometric combustion is the mass of air is equal to mass of air over mass of fuel is equal to EFR mass is equal to 11.5 WC plus 34.3, which is the WH, plus WH minus WO. So, and another one is the ideal plug flue reactor, which is PFR, another differential material balances. The ideal plug flue reactor is an open system resembling a tube with no mixing in the direction of flow but perfect mixing perpendicular to the direction of flow. Often used for systems like rivers and water pipes if the flow is turbulent. When a mass balance is made for a tube, one first consider as infinitesimal part of the reactor model. The mass balance is then integrated over the entire reactor volume to obtain. So, the formula, which is the D times Q sub A over dV is equal to R sub A. That's it.